This video is on the section 2.1 notes, frequency distributions. So in chapter 1, we talked about different ways to get a sample and to do it in an unbiased way, to use random samples. And now once you have a sample and you have the data collected, we're looking at how to make sense of the data. How to put it in a form where you can draw some conclusions from it. So the first method that we're going to study is a frequency distribution. A frequency distribution partitions the data into categories. We're going to call them classes with their corresponding frequency. So the frequency for a particular class is the number of data values that fall into that class. So over here you see a sample, data values that were between 0 and 14 minutes. There were 6 data values that fell into that range. For 15 to 29 minutes, there were 18 data values that fell into that range. Next, lower class limits are the smaller numbers that belong to a particular class. So here the lower class limits are 0, 15, 30, 45, 60. And then upper class limits are the largest numbers that belong to a particular class. So 14, 29, 44, 59. Class boundaries are the numbers used to separate classes, but without gaps created by class limits. So the boundary from 14 to 15 would be 14.5. The boundary from 29 to 30 would be 29.5. The boundary from 44 to 45 would be 44.5. On this class, the lower boundary would be negative 0.5. On this class, the upper boundary would be 104.5. Class midpoints are the average of the upper and lower limits of each class. So from 0 to 14, the midpoint would be 7. That's the average of 0 and 14. It's right in the middle. Class width are the difference between 2 consecutive lower or 2 consecutive upper limits. So 2 consecutive lower limits would be from 0 to 15, 15 to 30, 30 to 45. So the width is 15. You can do it with upper limits as well, 14 to 29, 29 to 44, 44 to 59. That's 15 as well. All right, so here we're going to learn the process for constructing frequency distributions. First, you choose the number of classes. Here they chose 1, 2, 3, 4, 5, 6, 7. They chose 7. This might be affected by the convenience of using round numbers, so you might choose specifically to create the number of classes based on your data points so that you can have round numbers when you start to pull your data out and create the frequency distribution. To calculate the class width, you're going to say the maximum data value minus the minimum data value divided by the number of classes. Again, you can round to result in a convenient number, and we'll see that's what they did here. Then you're going to choose a lower limit for the first class by selecting a value less than or equal to the minimum data value. So maybe in this data, the minimum data value was a 2, but they decided to go 0 to 14, and then 15 to 29, 30 to 44, just because those are round numbers that kind of make sense. Or starting at 0 and then going by 15s makes more sense than starting at 2 and going by 15s. Then you're going to use the class width to determine the rest of the lower limits. So once you knew that you were starting at 0, then you just count by 15s. Then you're going to find the corresponding upper class limits, and we'll go through how to do that. And then after that, you'll determine the frequencies by looking through your data and actually tallying it up. So this is the data that was used to create that sample table up there, and we're just going to kind of walk through those steps and what the person did who created that table. So they said 7 classes, which is what we could see in the table, And remember, classes are just categories. So when we say that there are 7 classes, we could see that they broke the numbers into 7 different categories. So the width is going to be the highest number in the table minus the smallest number in the table divided by 7. And I'll just direct your attention to it. The highest number in the table is right here, and the lowest number in the table is actually right here. There's a couple different 5s. There's one over here as well. So we're going to do the largest number minus the smallest number divided by the number of classes, which is 7. All right, and if we do that computation, 90 minus 5 divided by 7, we get 12.1 approximately. Now, you can see this is a decimal. I rounded it. We do not want to go by 12.143. We don't want to start with 5 as our lower bound or our lower class number and then go by 12.14 and then go by those decimals up. That would be pretty crazy. So instead, what they did is they took this and they rounded it to 15. We can see that they went by 15s. And so they rounded to 15, and they did that for convenience. All right, so we're going to start. You could have started at 5. They chose to start at 0. Okay, so we chose the lower limit for our first class. We know the width is 15, and we're going to use the class width to determine the rest of the lower class limits. So now we're going to count by 15s. So 15, 30, 45, 60, 75, 90. This is exactly what the person did who created that table. Okay, next, determine the corresponding upper class limits. So 0 to, if this one starts at 15, then this one must have gone to 14. And then from there, we just add 15 to each number. So 14 plus 15 is 29. 29 plus 15 is 44. 44 plus 15 is 59. 59 plus 15 is 74. If you are not comfortable adding the 15s, you can always just look at the next number and subtract 1 from it. Okay, so we have our lower class and our upper class. Next, let's go ahead and find our midpoints. Well, actually, we can finish this. It says determine the frequencies. So the frequency for 0 to 14, we're not going to do all of these because it would just take more time than we need to take because these numbers are not in order. So I'm going to look for any numbers that are between 0 and 14. So I've got this one. Okay, so 1, 2, 3, 4, 5, 6. That's how they got a frequency of 6, as there were 6 numbers that were between 0 and 14. And then they did the rest of the table. There's only one maximum value at 90, and so that frequency from 90 to 104, that's just 1, because there was only one number in that bracket. Okay, so you could fill in the rest, you know what it is from the table above, or you could look through the data and make sure that the table they had above was actually accurate. Okay, for the midpoints, you just take the lower class and the upper class numbers and add them together and divide by 2. This is you finding the average or finding the mean of those numbers. So 0 plus 14 divided by 2 is 7. So the midpoint here is 7. 15 plus 29 divided by 2. That one's hard for me. 22. Now, if the width for the lower bounds, or sorry, the lower class is 15 and the width for the upper class is 15, the width for the midpoints is going to be 15 as well. So for here, you can keep calculating them this way, or you could just start adding 15. So 22 plus 15 is 37, plus 15 is 52, plus 15 is 67, plus 15 is 82, plus 15 is 97. So those are all of the midpoints. I'm gonna label this midpoints, okay? And then down here, you do not have to write this out when you're doing this for an individual problem. This is just kind of to help you out. But this is going to help us calculate the boundaries. So the boundaries are the numbers that separate the classes. So between 14 and 15, we have 14.5. Between 29 and 30, we have 29.5. Between 44 and 45, we have 44.5. Between 59 and 60, we have 59.5. Between 74 and 75, we have 74.5. Between 89 and 90, we have 89.5. And as long as you use whole numbers when you create the classes, then you're going to have 0.5s when you go in between. So it's just half a number up from this, half a number down from that. So half a number down would be negative 0.5. Half a number up would be 104.5. So we could say the boundaries of the first class is between negative 0.5 and positive 14.5. Okay, let's look at another example. So you could see that when we did the previous example, that two different people in the class might get two different answers. We chose to do 7 classes. We chose to round up 12.1 to 15. We chose to start at 0. Those were 3 different choices that were made to represent the data, but a different statistician could have made different decisions. They could have had 6 classes. They could have, well, if they had 6 classes, they would have had a different number, but maybe instead of rounding to 15, they could have rounded to 13. And instead of starting at 0, they could have started at 5. And then your data would have still had a similar type of frequency distribution, but it would have been represented a little bit differently. So because of that, when you do these problems on MyMathLab, you're probably not going to be starting at the very beginning of those 6 steps. They're probably going to start here, where they tell you what the first class is. They're going to say the first class is 20 to 24 for this data, where they're giving you some information. They're giving you the lower class and the upper class. Hidden within that, we're going to find the class width. And so that's going to make it so we all get the same answer no matter who is approaching the problem. And that's specifically a MyMathLab thing, so that we can check different answers for accuracy, so that not everybody has different answers. So they won't always be presented exactly like this, but you probably won't be going through the entire process as we just laid out, just because everybody could have different answers. Okay, this example says construct a frequency diagram for the age information given below. So these are all ages. And then it says include both relative and cumulative columns. And so these are going to be new to us: a relative frequency distribution and a cumulative frequency distribution. Identify the class width, class limits, class midpoints, and class boundaries. The first class is 20 to 24. Okay, so if the first class is 20 to 24, then that means the second class is going to start at 25. And that is going to help me find my class width. From 20 to 25 is a width of 5. So 20, well, we would have subtracted those if the numbers were not as intuitive. We would have had to actually do the math there. So 25 minus 20 is a width of 5. And then we can figure out the rest of the lower widths, or not the lower widths, the lower classes by counting by 5s. So 30, 35, 40, 45, 50, 55, 60. Okay, and then for the upper classes, we can count by 5s from 24, or we can just look at the next number and do 1 less than that. So 29, 34, 39, 44, 49, 54, 59, 64. Okay, so the class limits here are 20 to 24, 25 to 29, 30 to 34. I'm not going to write them all, just all of those would be the class limits. Okay, let's go ahead and figure out the frequency. So the numbers between 20 and 24, there are 3 of them. This is a nice set of data because it's already been put in ascending order, so the numbers are getting bigger. 25 through 29, 5 numbers. 30 to 34. Okay, there's 4 numbers there. 35 to 39. There's 4 numbers there. 40 to 44. 4 numbers. 45 to 49. 3. 50 to 54 is 3. 55 to 59 is 2. And 60 to 64 is 2. Okay. Let's go ahead and find the other 2 columns, and then we'll figure out the class midpoints and the class boundaries. Okay, so the other 2 columns, the relative frequency distribution, is referring to what percentage of the whole are these data points. So to know that, we have to look at how much data we have total. So we have 3 rows of data and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns of data. So we have 30 data points. And if you add up this column right here, you should get 30. Because there were 30 data points. And so this is saying what percentage of the whole falls in this class, falls in this class, falls in that class. So this one would be 3 out of 30 data points, 5 out of 30 data points. Now these aren't percentages, so we're going to have to actually do some math in a second. 4 out of 30 data points, 3 out of 30 data points, 2 out of 30 data points. So we're going to have to type these into our calculators and see what percentage those are. So 3 divided by 30 is 0.1, which is 10%. And you can do that by moving the decimal over to the right twice or just multiplying it by 100. So this is 10%. There's a 3 down here. 10%. 10%. So 3 out of 30, those are 10% of all the data points fall in those 3 classes. 5 divided by 30, and we can multiply it by 100. 16.7%. This is going to be 13.3%. And then the last 2, 6.7%. And if we were to add up all these percentages, then our total should be 100% because 100% of the data is represented. You should never have a total other than 100% unless you have decimals that have made it slightly off from 100%, but it should be around 100%. If you're getting something like 150%, you have a calculator error somewhere. All right, cumulative frequency distributions, they cover everything. That's kind of what we think about cumulative. If we had cumulative tests, then for Unit 1, we'd have Unit 1 material on it. Unit 2, a cumulative test, would have Unit 1 and 2 material on it. A Unit 3 test that was cumulative would have Unit 1, 2, and 3 on it. A final that's cumulative has everything on it. So this, for the cumulative, that means it's going to be a running total. So for the 20 to 24 class, 3 of our data points were between 20 to 24. For the next class, we would say, well, how many of our data points were between 20 and 29? That would be 8 of them. The first 3 plus 5 more from that next section. Then if we include the next class, we would say, well, how many of the data points were between 20 and 34? That adds another 4 data points, so it'd be 12. The next one, we would say, how many of our data points are between 20 and 39? 16. In the next class, we would add another 4 data points, then 23, 26, 28, and 30. When you get to the very last class, you're representing all of the data. You're saying how many data points are between 20 and 64, and that should be all of them. So whatever your total is, it should be the same number over here. Okay, to calculate the class midpoints, we take the first category, the first class. We're going to add the lower and the upper class and divide by 2. So this is 44 divided by 2, which is 22. So 22 is the midpoint, and you can keep doing that process. Remember, you can do 25 plus 29 divided by 2, 30 plus 34 divided by 2, 35 plus 39 divided by 2, or you can say the width is 5. So from here, I just need to add 5. 27 is the midpoint for the next one, plus 5 would be 32. 37, 42, 47, 52, 57, and 62 would be the last one. All right, the class boundaries are the numbers that fall in between the end of this class and the beginning of the next class. So the first boundary, well, not the very first one. I'm going to come back to that one in a second. I'll leave a little space here. The first boundary I'm going to write to start with is 24.5. So leave a little space, 24.5. Then 29.5. Then 34.5. Then 39.5. 44.5. 49.5, 54.5, 59.5, 64.5 is the very upper boundary, and then the lower boundary would be 20 minus a half, so 19.5 would be where we actually started. And you'll notice that because the class has a width of 5, these go up by 5s as well. So everything is going to go up by 5s. All right, so as their name suggests, frequency distributions help us understand how the data is distributed over the range of the values. In statistics, we are often interested in determining whether the data has a normal distribution, which is characterized by being bell-shaped and symmetric. So what bell-shaped means is the majority of the data is in the middle, with the very middle being the most data. And then you can see that the classes that represent the largest numbers and the classes that represent the smallest numbers have lower frequencies. And then you can see symmetry here. So 18, 10, 4, 2. So this is what they're talking about when they're saying bell-shaped and symmetric, that there's the most in the middle and a little bit on the end. If you were to draw a picture of that, if we had a graph, and on the side we said like the number of data points that we had, then you would have not very many data points, and then a lot of data points, and then not very many, and they say this looks like a bell. And so normal distributions are what we are often interested in statistics. We'll study that more in a later chapter, but this will be something that you will be maybe intrigued to see if you look at data and notice that this is how the frequency table is represented.